Hello, everyone. My name is Timo Elliott, and I'm an innovation evangelist with SAP. Welcome to this installment of SAP's Big Data Chats. We're going to be talking this time about data science and data scientists. Who are they, what do they do, and why should you care? In order to discuss the topic, I have two other SAP employees with me, and I'd like to ask them to introduce themselves. First, let me turn to you, David Ginsberg. Who are you, what's your title, and some of your background?
Hello, Timo. Hello, everybody. My name is David Ginsberg. I'm the Chief Data Scientist at SAP, which means I'm responsible for the data science organization at SAP. For the last 20-something years, that's all I've been doing. I'm so pleased that there's now a title. I was tired, and my wife, I think, was very tired of trying to explain to people what I do. And so it's very exciting that now there's this very fancy, well-understood title called Data Science. Background-wise, I have a PhD from many, many years ago in automation and artificial intelligence, looking at the problems of big data from 20-something years ago, and also have advanced degrees in process control and electrical engineering a really long time ago.
Well, great. Welcome. And let me turn over to you, Shekhar. What's your role at SAP?
Sure. Hi, Timo. Hi, everybody. My name is Shekhar Iyer. I'm the Global Vice President for Analytics and Big Data, and really exciting times here at SAP. In terms of my background, I have a master's in industrial engineering and operational research. So grew up with the mathematics kind of junkie side of me, and was involved in supply chain optimization companies, been in the analytics, data management. So over 20 years in data, software, mathematics, all of the above jumbled together.
All right, and welcome. And my slight claim to fame is that I did do a degree in econometrics a long time ago, and I remember being able to state and prove the Neyman-Pearson lemma, but don't ask me to do it again today. So we're going to be talking about data science, so let me go back to you, David. I think many people will be surprised to hear that SAP has a data scientist organization. Who makes up the team, and what does your team do?
Yeah, it's quite amazing. Almost first of all, we're a global organization. Most of the folks on the team are PhD level econometricians, mathematicians, physicists. We have a lot of physicists, and we have a lot of engineers, as you can imagine. And we have some rather large groupings within North America, Germany, and actually a very nice and growing groups in both Romania, Bucharest, as well as the Middle East right now, who are doing some very large and impressive projects. So one of the things that's very unusual when we go to customers is almost the first statement out of their mouths are, wow, we're so used to SAP being just the same old software company, and are very surprised about how much we have to say regarding their strategy and how big data and advanced analytics can impact their strategy. Pleasantly surprised, I might add, and very much a key component of the end-to-end capability that SAP today offers.
Okay. And so let's try and nail down what we're talking about here today. So we have big data, we have data science, data scientists. There's a lot of controversy about the very word data scientist. There's a large number of people that believe that there's absolutely nothing new about the term, that this is just, as you say, a term for people who have been doing statistics for a long, long time. Is there anything that data science as a data scientist adds as a term to what we used to call statistics or business analytics? How about you first, Shekhar?
Yeah, no, absolutely. I do think that there is. It's a very natural evolution of where we've come from, and data mining and so-called analysis and analytics has been around for decades. But I think there's a few compelling forces that have happened over the last few years that make the rise of the so-called data scientists. It's how do you combine mathematics and statistics, visualization, how do you combine modeling capabilities in a high-performance computing environment? And I think that last point is very important because there is so much innovation in terms of technology that's happened that allows people to do things that they couldn't do before, and you need this new kind of skill set and breed that is able to bring these things together. So I really do believe that the data scientists are a new evolved breed from where the origins may have been. So that is really where I feel why it's very relevant and incredibly relevant for the kind of business problems we're trying to solve today.
Okay, David, what do you think?
Look, let's start out with the business imperative. 40 years ago, if you knew your industry and you knew your business and you had all that experience, you were probably going to be able to run a successful enterprise. Today, businesses are succeeding and thriving only because of various things that they can find for breakout performance. And so one of the last frontiers is really this collection of data. And so rather than being an adjunct or an afterthought about, hey, Mr. Analyst, can you analyze how we're doing, but you're not really part of being at the big boys table, what's happened is data science now is really at the forefront of strategy for companies. And so first and foremost, it's that business imperative that's really driving the imperative for data science. And then the needs are becoming much more sophisticated. So Shekhar touched on some very important points. It's the algorithmic aspects, having a very thorough and fundamental understanding of that, but in combination with both the front end and the back end of technology, all wrapped up in the industry-specific understanding of what you're trying to do for that particular industry. So it's a pretty tall order. And quite frankly, while software and SAP software caters to a very wide spectrum of folks, the data science role has to touch on very deep scientific knowledge. Ultimately, that gets piped into the business strategy.
That makes a lot of sense. So a data scientist would be somebody with a statistics background, but now somebody is really part of the new business model going forward. Data is the new oil. And so people are using data to make money, and that explains this new interest in those skills that have been around for a long, long time. I think it's also a question of maturity in that we've been using analytics for a long time, and according to various models, we've gone through the descriptive analytics. We now know what's going on. We've gone through diagnostic analytics. We have a rough idea of why it's going on. And now we're starting to go into predictive analytics, where these data mining and more sophisticated analytics come in. And hopefully getting on to prescriptive analytics, where the analytics tells us how can we do what we want to do using analytics. So David, what are some of the things that your team has been working on?
Yeah, I absolutely will get to that to answer your question, Timo, but I'd like to just add or extend that evolution that you suggested, which is data mining leading to predictive analytics. In other words, how will things happen in the future, and where we are today is also shaping that outcome. In other words, optimization. And rather than saying things are prescriptive one-answer solutions, what we're seeing an increasing need for is the trade-offs between. There's no such thing really as a one-number optimization. What there is an optimization based under certain assumptions. And just to give you a concrete example of what I mean by that, if you're a company, for example, who's looking to gain market share, then don't expect to maximize your margin, because perhaps you'd be happy to give up a little bit of that margin on your pricing strategy to acquire more customers. On the other hand, if you wanted to optimize margin, perhaps you'd be interested in increasing your profitability and losing some customers. So all of those are very sophisticated econometric concepts that can be and are today used in what we call decision support tools. Back to the question that you asked, we're doing all kinds of algorithmic things that are really touch the very heart of strategy. Some of the most interesting work that we're doing is really helping companies transform. One of my favorite examples is a very large utility in Europe. And I'll never forget these folks coming to us and saying, we've been in the electricity supply business for over 100 years as an industry. And it suddenly dawned on us that in today's paradigm, our customers are feeding electricity to us, what with windmills and electricity regeneration coming back into the grid. And so they are asking questions like, what does this mean for us? What does it mean for our equipment? And in fact, what does this mean for us as a business? It means we're getting into the data business. So my team has been very heavily involved in concert with SAP's technology as an underpinning to provide that transformational capability where they're able to do very, very sophisticated things, as an example. So you can imagine these SCADA systems that are picking up signals from many, many thousands of sensors. How do you process all of that in real time? How do you make that into some kind of strategic information? And those are the kinds of initiatives that my team's involved in. I could give you many other examples if you'd like me to carry on, or we can talk about them a little later.
We'll come back to them. I think we're allowed to name the company, because if you go to the saphana.com homepage and look for the data science services, they're actually named. And I've seen I won't name just in case, but I've seen a presentation from the people putting on the project, and it was absolutely fascinating. They were talking about the difficulties in what they called pushing water uphill. As you said, the grid has been designed to flow water out, and suddenly they're going to have to go the other direction. It was a huge optimization problem, and they had some very, very impressive statistics about how they were doing things differently.
And if I could just add to that particular customer, what was so interesting to me and really epitomizes the role of the data scientist and how companies are becoming more data-driven, is what started out as a fairly modest use case has become a ongoing road to additional enlightenment, if I can put it that way. And so finding out additional insights and new opportunity has led to more insights and more opportunities. And so that's a really big difference from the past, where we were a little bit siloed in our projects. Today we think much more longer term and much more about the portfolio of possibilities to build on one success on top of the other. That's very important.
And Shekhar, let me turn to you. Is this something that's just a silo then? Is it just for a few eggheads with PhDs, or is there something that the rest of us can take away from all this too?
No, Timo, I think that is exactly the point. I think the SAP strategy, one of the things that is most important is, for many, many decades, this has been a niche science and art that very few people with those deep skills have been able to leverage to solve the problems. And many times they've used the mathematics, but not fully, as Dave was telling about, really solved the magnitude of problems. What really we're trying to do is, how do we take this capability and make it more automatic and be able to so-called democratize the usage of data science for many, many problems. And I really believe there are almost three segments to this. One is what David and his team are doing, which is the deep, complex problems. Really, how do you transform business? But I think there's this middle segment, which has low to medium skill sets. How can they leverage the predictive advanced analytics to solve problems in a much more easy way? And the third category is, how do you embed this predictive capability into your daily lives, or applying it to the applications and things you're using? So I really think the pervasiveness of this is happening because more and more people are saying, hey, there is some tremendous value. How do I apply it to the specific business problems?
Okay, I think we'll come back to that a little bit. I've got one question here from Vijay Jayasankar, so thank you for the question. You tweeted earlier that you were going to be on a plane, so I hope your plane wasn't late. I think it's a question for you, David. what does a data scientist do in a typical day? And David, maybe you could address that and compare it to what a typical BI person or somebody who knows analytics. What's different about a data scientist day from their kind of day?
Yeah, first of all, hi Vijay, and thanks very much for the great question. Step number one, and I will speak for my team specifically, is we are extremely proactive about trying to understand the business imperative and translate it into English. How are we going to make our customers money? Yeah. So we are less worried about reporting, which tends to be a big focus of business intelligence. We are less concerned about documentation and much more concerned about how we're going to get to the heart of solving complex problems. And so BI and the data that supports BI is a subset of what my team does, and a very important subset, but it's really all about prioritizing the algorithmic opportunities that companies have, understanding, sifting through their data and setting up the democratized systems that Shekhar spoke about very eloquently to help people really at all levels in the organization, from the very strategic, where you need occasional decisions about where the company is going, to the more tactical, everyday decisions about how we're going to run our maintenance program. Are there the right kinds of spares? Do we deploy our capital correctly? So the folks on my team deal with everything ranging from the very deep science, setting up the algorithms, all the way through to how do you best leverage the technology, in many cases SAP's technology, but not exclusively. And so it's that intertwining of business problem, technology, and algorithmic science that really makes up our day. And we are obsessed and laser focused, to be honest, about the success of our customers. And I don't say that in any kind of cliche or trite way.
So you've been doing this for, 15, 20 years or so. You must be like a kid in a candy store. All of this data, all of this power is computing technology. Is it just a lot more fun than it used to be?
It is a lot more fun in some ways. In other ways, because of various other responsibilities that I have, I'm deeply envious of many of the colleagues on my team who get their hands a little bit more dirty than myself. On a personal level, I tend to get much, just because I've been at this for so many years and worked in so many industries. I tend to get involved very heavily on the front end, helping to articulate what we're trying to do. But you're quite right. In the past, when I was doing a lot of the algorithmic and hands-on work, we were always short of data. Today we have the opposite problem, and a big part of data science is, out of those thousands of dimensions or variables, which ones are really causal, which ones really impact. If this happens, then that will happen. And I'll just reflect on a project that we're doing on right now. Something that would touch you, Timo, as an old econometrician. We do a lot of econometric work, understanding demand, etc. But today, everybody's interested in unstructured data and social media. And so how do those econometric models, how are they impacted by how you treat your customers and what they're tweeting about you? Macroeconomics, for those people who are econometricians, out of the many thousands of variables and econometric metrics that are available today, which ones are really useful and valuable? So we're finding that our mathematical models are incorporating more dimensions, but an equally important part of our job is what to discard so that it does not become a distraction. Because trying to make a business person make a decision on 10,000 variables where maybe 10 or 15 are really driving results is a very important distinction to make.
So using all of this incredible, powerful number crunching and skilled expertise to ultimately make things simpler for the business person.
That is really a true statement. The important thing today is we do not have to exclude things because we can't handle the data. It's our job to whittle them down to the essentials. But that's a very important and subtle point is, in the past, one had to cut and paste because computing power wasn't able to deal with those. Today, we're able to deal with everything, and our job, in many ways, is to make the very complex very simple.
That's a great segue to you, Shekhar. So you've already made this point that you think it's not only about doing the data science, but really making that data science available to more people. So how do you think that looks in the future? You talked about the different segments, but can you give some concrete examples of what's been going on?
No, absolutely. And Timo, this is absolutely the segue to what David was talking about, that one of the fundamental things is data scientists are in really short supply. If you look at the McKinsey study that really brought to light a lot of these things a few years ago, there is far more demand than supply of these talented individuals. And the idea is, how do you leverage technology and automate this without losing accuracy and the effectiveness of solving problems? So let's take some fundamental examples. Like, for example, there are different business processes across whatever industry you have, whether it's telecommunications, finance, retail. Let's take, for example, customer relationship management. And I'll give an example to make it more concrete. Cox Communications, which is a customer of the SAP solution, really was struggling from the old legacy way of dealing with just kind of data mining capabilities. And they had a very small staff of just 4 data scientists, and yet they were bombarded with the business for different kinds of nuances on how to optimize their business, how to cross-sell and upsell, how to have a better handle on customer churn. And they were able to leverage the SAP solution and really automate that and create far deeper levels of personalized models and really get incredible business effects. And let me give you some examples. This company was able to cut churn rate by about 28%. They were able to quickly get over 10 million observations of 800 variables to really identify the customer-related issues. And this is exactly to the point that David was making. We have so much data now, it's about figuring out which ones really move the needle on the business, and then quickly focus on that, and to also try to automate that so that you're not spending a lot of time and effort and manual intervention and taking months to do it, what can be done in days and hours. And that is really where the business is going for this kind of solution in the marketplace.
Yeah. Okay, thank you. And we've got some great questions coming in from Twitter, so let's start getting to some of those. One here is from Sean Rogers. How critical is real-time big data to SAP client projects? Is the demand growing, and is it for analytic or operational systems? Who wants to take that one?
Let me have a first crack at it, and then Shekhar, you follow up. That's a really interesting paradigm shift. I'm an old process control engineer, and it's unbelievable how much I see the parallels of what we used to do to very large machinery and equipment 20, 25 years ago now happening for the enterprise. So let's take an industry. We're all shoppers, so we all feel like we understand retail. And it's very clear to everybody that retailers and merchants and operations folks in retail organizations spend an inordinate amount of time analyzing what has sold, what sells together, how to set up their pricing structures and the like. And suddenly you have this game changer in online retailing. Now imagine you, through the power of batch processing, deal with 100,000 products over a few thousand stores and set up all your mathematical models to forecast how demand will be for each store in each location, and you set up your pricing strategy, and one day at a particular time somebody just undercuts you on the internet. If you do not have the real-time capability to recognize that signal and do something about it, you may lose your entire business without realizing it. And so the complexity is, can you manage to sift through the signal from the noise real time, because there are so many signals happening? But if you can, how do you complement the rest of your strategy, which may be batch processing? So we see increasing amounts of needs for operational real-time strategy to be able to react instantaneously. And it doesn't take it's not very difficult to see how that impacts folks that have to make instantaneous decisions regarding pricing strategies, regarding capacity, and the list goes on and on. You know, you just think about transportation, for example. Something happens, you have to deal with passengers, you have to deal with crews, you have to deal with your assets and how to deploy them. These are the very essence of real-time operational challenges, where historically it was impossible to conceive of the kinds of things that we can do today.
And I think obviously the big new technology here is in memory. We talk about in memory for HANA a lot, and there's certainly the ability to run operational systems in memory. It gives us lots of new possibilities for using predictive algorithms in real time. But it's worth noting that in memory has been around for a long time, and the one thing it was used for was exactly this kind of business activity monitoring or complex event processing, and that's very much part of the SAP portfolio. Shekhar, any follow-up to that before we get to the next question?
Yeah, no, absolutely. I think the real time, that is what is changing, and why it is so, you know, in some ways everything looks the same, but in many ways it's changed very dramatically because of the very essence of responding in real time. And as David was saying, let me give you a customer example. A company called Allegro, which is an online marketplace based out of Poland, one of the largest in Europe. We are helping them with product recommendations that span like 50 million recommendations per month. Think about that. It is not possible that you could do that in a physical context, and this is happening in sub-second responses when somebody's coming in, looking at products, trying to make a selection. How can you quickly personalize and have a high probability target? Because what's happened is we were in a physical world and an online world, and quite frankly, we are in a hybrid world now. A lot of people are making purchases, but also a lot of people are doing their research. Like, for example, not as many people buy their cars online, but 90 to 95% are doing research online, getting armed with the facts. So if you're able to get to them and influence them and guide them in a certain way, you're able to get them in that real-time moment, even though it looks like they're going to walk into a dealership and figure out what they want. But a lot of that buying decision process has already happened. So you really do have to leverage that real-time and personalization ability in that context.
Okay, and I guess we're being too serious because we've got some flippant questions coming in here, so let me run them by you. The first is from Jamie Oswald. What can I call a data scientist that doesn't make my organization roll its collective eyes?
Well, first of all, I have a sideline where we do parties and blow balloons. Between the three of us, Timo, Shekhar, and myself, we all have funny accents. Hopefully we'll get you, Jamie, to roll your eyes all in the same direction.
And we have James Marlin chipping in here, said he used to have the title Director of Algorithms, which he made up, which it sounds pretty good, I must admit. It sounds good to me. Something a little more serious, but making it clear what you actually do. And then for even more comic relief, this is from Ohad Yassin. How many data scientists does it take to change a light bulb?
I'll leave that to Shekhar to answer.
Yeah. We will have to build a predictive model for that based on the attributes.
Yeah.
Okay. All right. Back to the semi-serious questions, if I can find them where I put them. Okay. Tammy Paulus, who's always very good at asking questions. Thank you, Tammy. Where does the data scientist sit within the organization? That's a great question. This is always one of the problems plaguing analytics, is how do you get a team that is close enough to the business and yet respects the particularities of a very technical role?
Yeah, I mean, I can take a cut if you don't mind. I think this really is the hybrid role, and this is what I meant by the evolution right at the beginning. They are very deep scientists, mathematicians, or background that comes from that. But it really is, I think, the more seminal concept of these data scientists to understand the business problem, break that business problem down, understand the elements of data that they need for objective analysis, and then applying the right technology and elements and algorithms to it. So it is a bit of a hybrid, but it's, sometimes it's on the business side, sometimes it's on the technology side, but the fact is they need both these skills to be effective in what they're trying to do. David?
Okay, David, let me go over to you, but let me add another part to the question, this time from Sean Rogers. So while you're answering that question, also, are data scientists collaborative in their approach, team-oriented, or are they lone rangers of data? I think it's probably part of the same answer.
Yeah, I mean, the lone rangers are dangerous. Because first of all, it's easy to be wrong, and without folks and colleagues checking and looking at over one shoulder the veracity of the results and the strategic importance of has to always be considered of the things that we're doing really needs to be taken care of. So we really are incredibly strong on teamwork, even though the characters that we tend to attract tend to be, myself included, very high maintenance folks. That was a joke again for Jamie. Just by our very nature, we always think we're right, but it over the years gets knocked out of you. And coming back to Shaker's point, his hybrid comment is a very important one. First of all, we've all agreed that finding these very scarce resources and in many cases very expensive resources is not something so easy. So what I've seen to be extremely successful is where there's elements of data science that permeate through an organization. Certainly, it's very nice if there's a small core of specialized folks. And then I would also, I'm unashamedly biased about the use of third-party teams like ours at SAP for the following reasons. We get to see projects, both the depth of projects as well as the breadth of global outside of all industries, which we are able to bring to the table. Folks within one company tend to be very focused and very easily are able to get caught up with only internal things. So the answer is if you're able to take the best of all worlds, to get some outside help, to have some internal specialists, and then also have folks that are populated within the business community that are able to leverage the democratized tools that Shaker spoke about. These three groupings of data science can coexist together, and today when we talk about in-memory as an example, it's really not about in-memory as a database, but much more about in-memory as a platform where all these three groupings of people, the very specialized outsiders, the specialized insiders, and then the business folks are able to all coexist and extend and work with one another.
And on that note, let me put in a pitch for a post by Charles Gadala, who is the product manager in charge of the SAP Predictive Analysis product, who wrote a really nice piece about basically the business knowledge and the technical knowledge for data mining to come together to build better models, so that a data scientist on their own can never have all of the context of the business people that are intimate to the deal. So you have to bring both together to build a better model. And let me flip that line. You said data scientists are expensive. Let me flip that around in two ways. One, I have a question here from Lee Clemmer. If you wanted to become a data scientist, if you wanted to earn that kind of money, what would be your recommended path? That's question one. And question two, what is the cheapest way to get access to these resources if I don't have a data scientist on my staff today?
Would you like me to have a first crack at it?
Yes. Is there any such thing as a self-made data scientist?
Well, like everything in today's society, there's always exceptions to every rule. The folks in our team almost universally have advanced degrees. There are ranges in experience. As you would imagine, in a team that's of fair size, some folks are there because of their more for the academic background, some more for their industry-specific knowledge. So there isn't one size fits all, but there is no getting around. If you're talking about the data science that we're involved in, we look for heavy hitters. And we're always happy to help any organization in whatever their needs.
Yeah, and Timo, let me take the second part of your question, is that, you know, there's obviously some training and education, and whether it's advanced degrees or deep industry knowledge to be effective as a data scientist. But I think that's exactly where I feel there are not enough of them today. And it's not easy for somebody to say, suddenly I'm going to go through a PhD program and pick up 2 PhDs. You know, that's not quite a short life cycle endeavor. And that's where I believe the automation and the skills, the capabilities of what data scientists brings, that is what we need to be able to do to make it more pervasive, so that people with some good skills can leverage this, that has already done a lot of the heavy lifting and can be applied. And that's where we really do believe that we are about to change the market from an SAP perspective, because not everybody can, as I said, enroll themselves into a PhD program. I myself was on a PhD track, but I thought master's and a bachelor's in mechanical engineering was enough and get to it. But at the same time, I love that, and I want to be able to apply it to solving business problems. So that's really my point of view.
Yeah, I think if I could just jump in, Timo, just to add what Shekhar is saying is, I think what we've come to is the clear differentiation between being the heavy-hitting data scientist and folks who want to take advantage of data science. The latter, there are incredible technologies today and capabilities where folks who are interested in the topic can really do a lot of very useful things without having to go through the rigors that the majority of the folks on my team have had to go through.
And if anybody is interested in learning more about data science, I just checked. The Khan Academy does a Data Science 101 selection of courses for people to get up to speed or to understand what's possible. I have lots of questions and comments coming in. James Marlin made a nice comment about the light bulb joke. He said that it was easy to ask and difficult to answer, which said everything about data science. Nice remark. I've got a couple of questions coming in about doubts and questions. I think one of the best qualities of a good data scientist is the ability to know what is possible and what isn't, and the amount of doubt there is in a model. So I've got two questions along those lines. One is from Neil McGovern. How do organizations test multiple correlations to separate false from true positives once the data scientists have finished? And a similar question from Shakti Bhushan. I observed that most of the modeling are deterministic, whereas in reality it's stochastic in nature. Any comments?
Yes, I could take both of those to start with, and then I'm sure Shekhar will have comments. Starting backwards, we're doing a very important work with one of the large European railways today, looking at the optimization of their inventory. Now, the inventory for their spares runs into the tens of millions of euros, so we're not talking about small little ball bearings. We're talking about very serious impact on capital deployment. And when one thinks about maintenance, there are two aspects of maintenance: the predetermined maintenance, as well as those events that we can define statistically but do not, we are not sure will happen, and that is what we refer to as stochastic events. We have built them a simulator, which is we're able to run many hundreds of times, many combinations and permutations, running through all possible scenarios to give them the best possible or the most likely outcomes of things that have not happened and may not happen. So we do combine both deterministic as well as stochastic events, and that's part of our job, is to be able to articulate those. With regard to modeling veracity, which means the accuracy of the model, really some of the rookie mistakes in data science is because the tools are so easy, one can think about it for those people who are not used to using tools. Think about your Excel and building a little regression model. It's the easiest thing in the world is to get an accurate or the most accurate possible fit, trying to use all possible variables, and then finding out that that model completely breaks down in the future. And so this is where we take complexity and try to make sure that the variables that are included in our mathematical models will hold up. And so there are many things that we do in reality to make sure that we maximize accuracy, but also the robustness of the model. And that's really part of the role of the data scientist.
Yeah, no, exactly. And to David's point, that is where some of the technologies that we have exactly build on that. How can we, through machine learning, figure out the real robustness of the model? Because that is really important. And then the accuracy. But there's one thing that's very important. We talked about real time. Time is a very important element here. That models and anything that you define has a very fast attrition, especially in this day and age. So what you need is the ability to constantly learn, improve yourself, or the models that are predicting, so that you still have the accuracy level that you started off with. So I think you have to combine these two elements to really be able to constantly solve the problem. And I think that's a very important point. And that's why you want to be able to compress the life cycle of doing that, because the question you ask, the answer has probably changed in the time frame that traditional methods are used today, and that's why it's really important.
Yeah, just if I could give two customer examples of exactly what Shaker has spoken about. The one example is our organization happens to have some very specialized intellectual property in the retail area to mathematically model the demand for sales in retail. And these models use, I'll use a fancy word here, Bayesian learning to assess in new data, do we warrant updating the parameters? And why that's relevant is, imagine the economy suddenly changes. It's 2007, 2008. Shoppers become much more sensitive to price. The fact that price elasticity will suddenly start to change is incredibly important to understand and predict your demand. And exactly as Shaker pointed out, your mathematical model should be able to update and learn how things are happening. Another good example is, we happen to, for those people who are football fans in the United States, I would encourage you, I certainly know my son's a big fan of fantasy football. And one of the most elegant examples of SAP technology and data science out there is the NFL fantasy comparison tool. And there's many models that is driving that tool. For those people who are listening, you can actually go out to the fantasy website, and out of these dozens and dozens of models that is driving that website that was set up by our team, by the way, those models are updated every single day.
It is a fantastic example. Let me just point out a couple of things. One is some people have found it hard to find. So you do actually have to have a fantasy team before you can access that technology. And once you're there, then it's buried in some of the menu options. But as soon as you know that it is there, you'll be able to find it. And second, I heard at least one person complaining because they had been used to being better than everybody else by simply spending more time doing the calculations manually themselves. And so they were complaining that now all this power is available to everybody. They'd lost their edge, which I thought was funny. Let me go to some more questions. I think I've got a great one here from Henry Morris, analyst with IDC. Thank you for joining us, Henry. What skills do people need in marketing, finance, or logistics to be able to work effectively with data scientists? So what does it take for an organization to get the most out of a team like yours, David?
I was going to make a joke about being able to write a check, but the truth of the matter, the truth of the matter is, first of all, a willingness to be successful. You'd be amazed at how many companies succeed or fail depending on the mandate. and the desire to make analytics and big data a key or central part of the way that they do business, that's an incredibly important tenet. And then, we have very strong skills in being able to interact and share our experiences with the kinds of business experiences that a particular group like that marketing group would have. So, communication, unsurprisingly, would be a very important part. We separate technical and business needs, starting with business needs. What is it that you're trying to prioritize, getting that shortlist, and then going on the technical side and saying, what data do we have or could we have? Because that really has changed now to support getting those insights. And one of the things that we would do very quickly is to substantiate that the data, in fact, is providing all the dimensions to getting those insights. So, I really like to think about it as, imagine you lived in a two-dimensional world and suddenly were exposed to the fact that there's a third dimension. The aha factor would be enormous. And so similarly for that marketing group, it might just be that one extra data feed coming from unstructured data, and where we help them see that, and whether it was heavy duty help from our group or really something where we could help set up some of the technology that Shaker spoke about, which would be fairly straightforward to use. Those would be guidelines and help that we would provide them. So, that is, it's not a very difficult barrier to work with SAP in general or our group in particular. We tend to make it a fairly enjoyable process.
So we've talked a fair amount about how to access our data scientists and data science teams. Let's flip it a little bit to what you've been saying about the rest of the world, data science and data mining for the rest of us. More concretely, what kind of tools are available for somebody who wants some of this advanced power but doesn't have a data scientist on staff and isn't likely to anytime soon? What can we offer them?
Yeah, Timo, I think this is where you'll see that the SAP strategy is really, over the last 2 years, picked up steam. This is an area where we really believe there's a tremendous amount of value we can add. And there's a couple of things. SAP embarked last year in building its own predictive analytics. And recently, a few months ago, we acquired a company called KXEN. And what was really unique about KXEN in the marketplace was it really was trying to do what we talked about. How do you democratize the usage of predictive and advanced analytics to those business problems? Now, there are always going to be that segment that is very complex, very deep, very nuanced, that teams that David manages and others in the world do are going to be leveraged. But there are still tremendous amount of white space where just simple things like CRM analytics, risk, fraud, etc. If we are able to embed that analytics in an easy-to-use way without the complexity of knowing what is linear regression and how to apply neural networks, but knowing the business problems and frameworks, what's needed, and having enough of the data, we are able to provide those kind of solutions with a high level of accuracy and really be able to do that in a very fast time period. And the good thing about time is you can iterate many times and get to a much better solution. And as David said, sometimes this is a bit of an iterative process. Does this affect? How much does it affect? Which ones do affect? How can I get that data? How can I test it quickly? And then make the recommendations for business to do something and get the actual business benefit. So we have some solutions that are very, I believe, very powerful compared to what legacy tools are. And also our big data platform and what we have to be able to really get that data and leverage huge amounts of data in a real-time fashion can really expose new ways of doing things that people didn't see that they could do.
Yeah, I want to echo what Shaker said, because we love it when people get their hands dirty and start to visualize what's going on in their data. Obviously, SAP has some tremendous visualization tools. Business intelligence tools, the platform that he spoke about, and then obviously the various analytics tools. So, the beauty from my point of view is it doesn't matter where you start, whether you have a predefined mission-critical problem that you want to solve, and that's going to get you that ROI, and you engage with a team like mine, or you say, hey, we've got lots of analytic problems and we want to become an analytics company, starting off with the everyday and then driving and finding out about new opportunities in insights. All these different groups should be catered to without having to throw one effort away and replaced by another. This is a big change from...
Exactly, and Timo, let me just make a comment to an earlier comment you said, somebody who was doing a lot of manual calculations on that NFL fantasy site. This is exactly it, and look at what he said. Oh my God, with this tool and technology, suddenly my competitive advantage has gone away. And I think that's really the moral of the story here, is that companies who are sitting and waiting whether this is hype or something they can do later are going to suddenly find all their competitors who have taken that proactive approach, applied, whether it's services with deep domain expertise or technology or some combination of it, they're going to be at a distance. And the world just gets more complex with more data and more problems and more nuances. And if you don't find a way to control that, you are going to be at a competitive disadvantage, whether it's the fantasy football where you're betting with your friends or really billions of dollars shaping the future of your industry.
That's a great point. Yeah, even if you're not in the football business, you can certainly learn something from the NFL fantasy tool. I got a question here from Vijay Sankar. Thank you again. Last question from him. In the future, will predictive be part of every BI solution rather than a standalone solution by itself? Yes or no?
No, it's always a combination. I think there's going to be embedded analytics that are going to be in a lot of the business processes, and we are doing that with SAP. And yet, there are going to be situations that needs a certain specialized custom framework, and we're going to be providing that. And that's really the beauty of our platform, is that we provide both. And I think you do need both.
We're getting down to the quick fire round as we get towards the top of the hour.
Right.
So there's still some questions.
The 2-minute drill.
Exactly. Another one from Sean Rogers. Do you see customers integrating social data into their big data projects? If so, what type is most popular? The answer is obviously yes. Any short color you can give on that?
Social analytics, sentiment analysis are simple, easy things that have clear causality.
Yeah, and and actually what we're finding is really out of all these potential new data streams, the opportunity is finding out which ones do have causality to whatever it is that you're trying to predict better. And certainly when it comes to the customer experience, the unstructured sentiment data that Shaker mentioned is becoming incredibly important. You just cannot ignore it anymore.
Yeah, and in fact, you should go. If I could just give a really good example of this, is KXEN was leveraged for the Obama campaign, where they leveraged a lot of the social network and Twitter feeds, and they did a phenomenal job, and the chief data scientist there leveraged it. So here, that's an example to definitely go and check out on the website.
And the point I'd make about social data is there's lots and lots of different tools out there for analyzing social data. But of course, if you're just looking at the social data, the tweets, the likes on their own, then it's useless. You have to correlate it with all the other variables that you actually care about. All right. We've talked a lot about SAP, but SAP is much bigger than just us. What about data science and the general ecosystem? What about SI partners, other technology partners? Any comments there? We signed a deal recently with SAS that we should probably mention at this point.
Sure. No, absolutely. Let me take that. I do believe that, the world is bigger than just SAP, and there are two factors to this. One is there are a lot of investments that customers have made, and we need to be open and agnostic and yet provide the value we can, and we are totally committed to that. The other thing is, as deep and talented as David's team is, it is a small relative team, whereas we really have aspirations to touch every part of the world. We have partners that are in Japan that are distributing and doing services. and really all over the world. So that's just one example. And they bring their own domain experience and expertise, whether it's in an industry or a sub-industry or a process, and we really want them to be able to leverage what we have in terms of the tools and solutions and platform, and also create these kind of rapid deployment solutions that are able to get accelerated deployment. At the end of the day, it's how does a customer get quick value to that. So we have a program, a go-to-market strategy, where we are working with a number of partners that are out there, and similarly, we have we leverage R. It's an open source solution that helps get skill sets that customers may have, leveraging our platform and other elements. So it is that openness that we have, and I think that's the way to look at SAP, is really taken a very important look at the strategy, keep it open, agnostic, and open to the partner ecosystem.
And I'd like to think we're doing our part in educating the world. For example, every single one of the predictive algorithms included in SAP HANA, there's a video available on the SAP HANA Academy website, experience.sap.com, where you can go and find out more about how to use it. A quick comment from James Marlin, noting that the Ariba network also is gathering lots of information, and that's a potential source for more leveraged insights in the future. I think that will be a great resource as we move forward to business networks. Now, we're down to the final few minutes. So where is this going? This is the big picture in the next 5 years. What are some of the big trends beyond what we've just talked about? What can we expect to see in the coming years? What's going to really change in this area? How about making some predictions about predictive?
Well, there's two things that I would, there's of course many, we're limited in time, but the two comments that I would share is I predict that the commercial models between one customer and one supplier is going to change to many. And so, an example is we're working with a company that operates, that builds and manufactures some very foundational equipment that's used in many different industries. Today, because of the real-time predictive maintenance that we've spoken about earlier, we're now helping many customers all at the same time. And so if you extrapolate that a little bit, it starts to make the propellers turn about, well, how will that change commercial arrangements? And so my one prediction about the future is the very concept of one-to-one will become many-to-many. And then the second one, which is obviously a very big theme for SAP in particular, is cloud and virtual computing, and certainly it's going to be a back to analytics as a service, being able to extrapolate and make sure that we're able to support many customers from a relatively small group of people to help with that democratization.
Yeah, Timo,
what about leverage? Sounds great.
Yeah.
I'll take an example on give an example on how it's going to go. I look at it as the car industry has evolved. We built cars, we built the stick shift, we have automatic, and now it's almost self-guided cars. I think that that's the path of how advanced analytics is. It was, in a way, very manual intensive. We are providing today the capability to do automation. It's going to get more embedded, and it's going to learn itself and create the richness and improve with the intelligence and the promise that has always been there. And it's going to give, with the level of human intervention that's needed and control, make it more automatic, just like what Google's doing to cars, right? Self-guided. So I think that's really the path. That is the future. It's just a question of how fast will we get there.
Okay, that's wonderful. Now, there are some questions that we didn't quite get to so far, but the good news is that many of these can be answered by going to the saphana.com website. So one from Peter Hebley: could you name examples of business areas where data science will certainly have a great impact in the short, medium, long term? So there's a whole bunch of examples of different. Is there any particular industry that jumps to mind as particularly ripe? Basically any industry that has data, which is all of them.
There isn't an industry that doesn't need it, honestly, Timo. So
Okay. And well, with that, then let's just wind down. Any we have a minute to go. Any final thoughts first from David with the in Scottsdale, Arizona, despite his accent.
That's right. We were talking earlier, Timo, that with the names like Shaker and from Sweden, Timo sitting in France, and a South African accent sitting in Arizona, we're going to really confuse everybody. My final comments are as follows. Rather than considering data science as a threat, I see it as really making everybody's job more strategic. And so it's an opportunity for all of us and our organizations to escalate and elevate our game.
Wonderful.
And my final thought is, don't lose the competitive advantage. Things move too fast. This is truly a great way to move your business forward, and you will actually add value to yourself and your organization by learning, adopting, and leveraging it.
All right. Well, that's wonderful. Thank you, everybody who has been listening. Thank you for everybody that asked questions. Thank you for some of your kind remarks. One person says that you have proved that data scientists have a sense of humor, which is very nice. So thanks. We're out of time, and we look forward to seeing you at the next SAP Big Data Hangout. Thank you very much.
Bye-bye, everyone.
Thank you. Bye.
Bye.